All right, have a look at this one. It says prove that 1 plus x is greater or equal to 2 root x. Now, if you remember the common one we use to be greater or equal to 0 is a minus b all squared. You could just do a substitution in that. That would give you that. So you can see we could, for example, let a equal 1, and then that would be root x. Because if I sub that in here, I would get 1 plus root x squared, so that would be x is greater than 2 times 1 times root x. So I would get 1 plus x is greater or equal to 2 root x for positive x's. So that is just because we can only square root positive x's or zeros. So yeah, so we're just substituting. That's one way to do it, just to substitute in there. Also, if we look below, we've got 1 plus x, 1 plus y, and 1 plus z. So we might want to just go similarly. We know that would work for y and for z. So have a look at that. And then you can see we want to multiply them this time instead of add them. So multiplying, we could call them 1, 2, and 3, but multiplying them, we would get the 1 plus x and the 1 plus y and the 1 plus z on the left is greater or equal to, everything's positive here, we're assuming. Alright, and it's greater than, so we've got 2 times 2 times 2, which is 8, and then we've got root x, y, z, if we put it all together. Now, look at what we want. We want it to just equal 8. Well, suppose that x, y, z, oh yeah, it is positive, good, they're all positive, so we can do this multiplication no problem. And, oh, it also says suppose that this equals 8. Alright, so if that equals 8, if we use that supposition, so given that, maybe I'd say that, given that, then this equals 8, and this is 8 x, y, z, so divide both sides by 8, and you would get x, y, z, or square root of x, y, z, is less than or equal to 1. We know x, y, and z are all positive, so we can actually just square both sides and the inequality holds. So we will get x, y, z is less than or equal to 1.